So, example 2 of definite integration with substitution. And then just like the last time, I'm just going to ignore the limits to start with. So 2t e to the 5t squared dt. I'm going to ignore limits. And we'll put them back shortly. So first of all, I'm going to take the 5t squared and make that our u, our substitution. So 5t squared. So du by dt is going to be 10t. You see we're going to get at least the t's will cancel here and here. So that can go back into there. It's not quite that because we need to say what dt is. It's du over 10t. So I'll just go in here. 2t e to the u times du over 10t. And then the t's will cancel. So let's do that. T's cancel. And the 2 cancels the 10 to leave 5. So I'm going to write that as 1/5 of e to the u du. So now I need to put my limits back, of course. And the limits were 0.1 and 0.3. So these were x equals 0.1 to x equals 0.3. So I'm going to change those to u-type limits. So at x equals 0.1, u will be, well, 5 times 0.1 squared. 5 times 0.1 squared. That comes out at 0.05. When x equals 0.3, u is 5 times 0.3 squared. And I think that's a job for a calculator. 5 times 0.3 squared is 0.45. So now we can write this as 1/5 of e to the u du from 0. Oops, try that down, 0.05 to 0.45. Now I can now integrate that, and I could integrate it as 1/5 of e to the u from 0.05 to 0.45. But also what I could do, okay, so I'm going to raise this for a second, because that's correct and it will give the correct answer, but an alternative strategy is to take the fifth out of the integration because it's a constant. So we'll take the fifths there. Integral 0.05, 0.45 e to the u du. Then that's 1/5 of this thing here. So e to the u from 0.05 to 0.45. So that is 1/5 of e to the 0.45 minus e to the 0.05. And again, that's one for calculator. So calculator, let's drag over here. And we can see here, well, I'll do the bit in brackets, e to the power 0.45 subtract e to the power 0.05 comes out as that, and then it's a fifth of that, so we'll just do divide by 5, and we get 0.103. 0.103, and that's the answer. You can see that in the example when we work down 0.103. So that's good. So in the next lecture we'll look at example 3, and this has got a really significant trick in it.